Good morning. Today we're looking at factoring some special cases of trinomials, starting with our perfect square trinomials. So in our perfect square trinomials, we have trinomials that are in the form of a squared plus 2ab plus b squared, meaning both the first and last term you can take the square root of, and then they would factor into two parentheses like this, or since they're both the same, we can write it as a plus b squared. Let me give you a number example here. So let's say we have x squared plus 8x plus 16. X squared and 16 we can both take the square root of, so we get x plus 4 and x plus 4, and since those are the same, we could write it as x plus 4 squared. Our other option is we have a squared minus 2ab plus b squared. In that case, we would factor into a minus b times a minus b, or a minus b squared. Number example for this one would be, let's say we have 4n squared minus 12n plus 9. Both the first and the last term you can take the square root of, so we have 2n minus 3 times 2n minus 3. And since those are the same, we can write it as 2n minus 3 squared. Alright, so let's look at some of these. X squared and 9, we can both take the square root of. There is a plus right here, so that means both of my parentheses are going to have a plus in the middle. The square root of x squared is x. Square root of 9 is 3. Both of these are the same, so we'll write it as x plus 3 squared. Alright, number 2, there's a minus, so both of my parentheses get a minus. First and last one we can take the square root of. Square root of x squared is x. Square root of 49 is 7. Number 3, plus right here, so both of my parentheses get a plus. 4x squared and 25, we can take the square root of both. Square root of 4x squared is 2x. Square root of 25 is 5. Both parentheses are the same, so we can combine them. Oh, we forgot to do that on number 2. Both of these are the same, so we gotta combine them into one. And number 4, there's a minus right here. Both parentheses will get a minus. We can take the square root of both the first and the last term. Square root of 16x squared is 4x. Square root of 81 is 9. Both of these are the same. We will write it as 4x minus 9. Alright, so that's the first special case. Now our second special case is called the difference of two squares, which means we got a squared minus b squared. There's no middle term in these. So these would factor into a plus b times a minus b. Again, both the first and the last term are a perfect square. So for example, let's say we have x squared minus 64. Both the first and the last term are perfect squares, so we can factor into x plus 8 times x minus 8. Or let's say we have 25x squared minus 36. Again, both the first and the last term are perfect squares, so we can factor it into 5x plus 6 and 5x minus 6. Let's look at number 5 here. Both of these terms are perfect squares. The middle is a minus, so that means we can factor it. So x minus 3, x plus 3. Both of these are perfect squares, so we can factor it. X minus 10, x plus 10. 7, both of them are perfect squares. So x minus 4, x plus 4. Both of these are perfect squares, so 5x minus 8, 5x plus 8. Now number 9, at the first glance, we're going to say, oh, nope, those are not perfect squares. But if I take out the greatest common factor, which in this case is going to be 12, I get x squared minus 4. And 4 is a perfect square. So once I take out the greatest common factor, this inside of the parenthesis will factor into x minus 2 and x plus 2. So that does work. Over here, we're going to take out the greatest common factor again, because all of them are divisible by 3. Now this one isn't going to be a difference of 2 squares because we got three terms, right? But this is one of the ones that we just did on the last page, right? The first term is a perfect square, the last term is a perfect square. So that one we can turn into 2x plus 1 times 2x plus 1. Both of these are the same, so we can combine it into 1, making that parentheses squared. And that is it. Go ahead and give the homework a try. You're going to see both of those types of problems on there today. If you have any questions, make sure you come by and see me. Otherwise, good luck.